Geometry. Welcome to our new online learning adventure. We are going to do our best. We're all in this together. I'm kind of excited about it, kind of nervous about it, but it'll all be okay and we're all in this together. So when we left off in class, we're just finishing up talking about finding the volumes of 3D figures like cones, pyramids, prisms, and cylinders. So now we're going to move on to something new, and it's kind of a throwback to when we talked about transformations, things like translations, rotations, reflections, and dilations, except we're going to put them on a grid now, like on a coordinate plane with an XY axis. So the first two that we're going to talk about are translations and dilations. We're just going to focus on these to start with. Remember, a translation is like a shift. The size and the shape does not change. You just take an object and you slide it somewhere else. The second one is a dilation, which uses a scale factor. And that scale factor doesn't change the shape at all. It has the same shape, but it's either going to make the object or the shape bigger or smaller in size, depending on the scale factor. Now we're going to start by talking about translations. So the first thing I want you to do is just imagine that you have this grid right here. Okay, so look at that grid and think that we have some shape, this beautiful little triangle, and we are going to translate it over there. Now in the past, we just said, okay, well, we're going to translate it along that directed line segment right there. But really, what's happening is we're taking each point here and we're moving it to a place over there, according to that line segment. Now, on a grid, we have all these nice lines that go to the left and right, across, and they go straight up and down. And so as we transform or translate things on this grid, we're going to take advantage of those lines. So instead of going on this diagonal, we're going to talk about it as going some distance to the left. Let's just say that if this grid had numbers, let's just say that that's like 4 more to the left. Or sorry, to the right. Sorry, 4 to the right. And then let's say that it's going up 3. So essentially, instead of taking this diagonal thing here, we're going to take every point here and we're going to move it 4 to the right, and then up 3, and it ends up in the same place as if we just would have done it on the diagonal. It's just taking it, following the grid lines to get there instead of just on a diagonal straight across. Now really what's happening, if we wanted to describe what was going on, is we take every xy, and we know that the x is the part of the order pair that tells you the left to right. So that, in this case, we're going to take each x and we're going to move it to the right 4. So we're going to add 4 to all of our x coordinates over here. And we know that the y is the part of the order pair that goes up and down. So we're going to take all of our y coordinates and we're going to move them all up 3. So we're going to say y plus 3. So this is a way that you can describe what's happening, describe a translation, not by just talking about the directed line segment, but by using ordered pairs. We're saying we're taking every point here and we're going to move it 4 to the right and 3 up. So we can think about if we had just some ordered pair, and let's say we had a new translation. Let's say we had this one. We had x, so the x just stayed x, and then the y became y minus 5. So what does that mean? What is that talking about? So this x, because there's no shift attached to the x, there's no plus or minus out here, the x coordinate just stayed the same. In this translation, it doesn't go left or right at all. No left or right shift, because there's nothing happening with the x coordinate. The y coordinate, however, is a little bit different. We're saying that we're taking every y coordinate from over here in the original image, and we're going to bump them all down 5. So this is going to actually take our object and shift it 5 units down. So for example, let's say we had the point 3, 9. according to this, so this is just an example here. According to this rule, the x stays the same. So what is 3 over here is still 3 in the new shape. The 9, however, is not a 9 anymore because it moved 5 units down. So the 9, if we take that 5 units down, now it is at 4. So according to this translation, this ordered pair moved there. It didn't shift left or right at all, but it moved 5 units down from 9 down to 4. Now the other way that we can describe or talk about transformations on a grid is with dilations. Now remember, a dilation is talking about making something bigger or smaller. So let's say that you have some point, and we're going to take every x value and we're going to double it, and we're going to take every y value and double it. That means that all left to right distances are going to be doubled, and all up and down distances are going to be doubled. So if you do this, you would have a dilation using the origin as a center. And in this case, the scale factor would be 2 because you're multiplying every x and every y by 2 in a scale factor of 2. So for example, if you had a shape here, now here, this is going to be some xy ordered pair. But now we're going to multiply the x by 2 and the y by 2. So the new point is going to be like out here, and then it went up that far, so now it's going to be going up twice that far. This one is going to take that distance, and it's going to go twice as many x, and then it's going to go twice as far up. This point up here, it's going to go out that far, so it's going to do twice that. And then it's up that far, it's going to go twice that. So by doubling each of the x coordinates and doubling each of the y coordinates, you essentially make a dilated shape using the center as the origin with a scale factor of 2. Now, one thing you have to watch out for is, let's say you have something that looks like this. This is not going to be a dilation because this just doesn't take the shape and make it bigger. This, oops, sorry, you can't see it. This is going to take the shape and actually change the shape of it. So what you're going to have here is your x distances are all going to double, but your y distances are going to multiply by 5. So what was the bottom here? It's going to be twice as long. But the y values are all going to be multiplied by 5, so it's going to stretch it out up high because it's not expanding in with the same scale factor in all directions. So this is a dilation. This is not a dilation. In order for it to be a dilation, you have to multiply each of the coordinates by the same number. Otherwise, it's just going to stretch it and it's not going to be the same shape anymore. So this, not a dilation. So I hope this video was informative. If you have any questions, feel free to send me an email. Go ahead and try the practice in Google Classroom. It's a Google form. Just try your best. Remember, you can take it more than once. If you don't do well the first time, you can take it again. You can rewatch the video. Also, a completed copy of these notes is going to be uploaded into Google Classroom too, so you can just look at that and you can see everything that I have written here. Thanks, and I will see you later. Bye.